This is a live view of United Launch Alliance's new Vulcan rocket on Launch Pad 41 at nearby Cape Canaveral Space Force Station. It will launch a spacecraft that will land on the moon, making it one of the first lunar landings for the U.S. since the final Apollo mission over 50 years ago. Good morning, and thank you for joining us on the Space Coast of Florida. I'm NASA's Megan Cruz, and you are watching the first launch of NASA's CLPS initiative. CLPS is short for Commercial Lunar Payload Services, a model in which NASA contracts space on commercial missions to send science and technology to the moon. These deliveries will mean more exploration of the moon than ever before and will help us prepare for the first woman and first person of color to land on the lunar surface under NASA's Artemis program. For today's launch, NASA selected Astrobotic to deliver its 5 lunar instruments. This is the first mission for the Peregrine spacecraft. Today is also the first launch of ULA's new Vulcan rocket, so a lot of firsts today. Now we have a 45-minute launch window that opens at 2:18 and 38 seconds Eastern time. But you'll notice that clock on the upper left-hand corner of your screen. It says T-minus 7 minutes. That's because the ULA team is in a planned hold. Basically, they baked extra time into the countdown to make sure everything's good for launch. You'll see that clock start to count down again when we are actually 7 minutes to the opening of the launch window. Helping me to share today's firsts are commentators from both our commercial partners. We have Astrobotic's Olivia Chapla, but first, let's start with ULA's Amanda Sterling with a check of how the rocket is doing.
Thanks, Megan, and good morning. I'm Amanda Sterling, a structural engineer and program management leader at United Launch Alliance. I'm joining you from the Advanced Spaceflight Operations Center at Cape Canaveral. This is an exciting place to be as the ULA team counts down to liftoff of Vulcan's inaugural flight. Right now, the Vulcan booster and Centaur upper stage are fueled while the launch team continues final preps. As Megan mentioned, the launch count remains in a planned hold. The ULA team is currently not working any issues, and we're on track for an on-time launch at 2:18:38 a.m. Eastern. Coming up, Space Launch Delta 45 will provide a final weather briefing in about 15 minutes. At the moment, our weather looks good with just a 15% probability of violation through the 45-minute launch window we have available this morning. Now, I'll send it back to you, Megan.
Thank you, Amanda. It's great to hear that 85% go for tonight. Now let's take a closer look at the Peregrine 1 spacecraft. It's about 6.2 feet tall and 8.2 feet wide, made mostly of aluminum and carbon fiber. The 4 landing legs have a honeycomb design on the inside to absorb Peregrine's touchdown on the lunar surface. Its solar panel is mounted to the top of the spacecraft. The payload decks at the center will carry 20 payloads from 7 countries. And finally, it has over 1 mile of cables and wiring. Our broadcast on NASA TV today will cover Peregrine separation around 3:09 a.m. Eastern Time, followed by acquisition of signals shortly after. For more on the company that built Peregrine, here's Astrobotic's Olivia Chapla.
Thanks, Megan, and thanks to all of you for tuning in. I'm Olivia Chapla, and I can't tell you how pleased I am to be here representing Astrobotic as the Director of Marketing and Communications. We're a small but mighty team of about 260 people. Together, our real goal is to make space accessible to the world, and today we are particularly focused on the moon. Astrobotic built the Peregrine spacecraft as part of our fleet of lunar landers designed to deliver cargo, called payloads, to the moon's surface. Over the past 3 years, I've watched the Astrobotic team build this Peregrine spacecraft launching today. I've been there alongside them during the long days, late nights, and for the ridiculously early mornings when we shipped Peregrine to Cape Canaveral in preparation for launch today. I am personally so excited to be here because this mission really marks the beginning of a historic time. The United States hasn't soft landed on the moon since NASA's Apollo program more than 50 years ago, and only a handful of countries have ever successfully landed on the lunar surface. Astrobotic's aim is to not only return the American flag to the moon again with Peregrine, but also to start regular commercial lunar deliveries to the moon's surface. Now, let's hear a little more from our founder and CEO, John Thornton.
Astrobotic's goal is to make space accessible to the world, and what that means to us is making it possible for space agencies and commercial organizations, and ultimately the individual all around the world, to access the moon in ways that have never been possible before. The big thing that we're known for is our 2 lunar missions to go to the surface of the moon. Our first one is about to launch, and our second one flies in 2024. Astrobotic already has a wide array of contracts from rovers and landers, and now the beginnings of power systems that can be deployed on the surface of the moon. So we are not only thinking about lunar delivery, we're thinking about the next step. We're thinking about rovers that can drive. We're thinking about power systems that can deploy and provide sustaining power at the poles of the moon. These are all of the pieces that we need, the infrastructure that we need to take our next step, to make the moon a place that we can sustain and live and have astronauts do science and exploration, and one day use the resources of the moon for in-space purposes and perhaps eventually bring those resources back to Earth. Pittsburgh startups, and space startups in particular, are not supposed to succeed. You're supposed to be in Florida, you're supposed to be in Houston, you're supposed to be in LA, but yet here we are in Pittsburgh with our very first spacecraft on the launch pad, ready to go. We have more than a dozen instruments flying on our very first mission from all over the world. 6 new nations will touch the surface of the moon with just our first mission. This mission was done on a relative shoestring budget. This is a much more affordable mission than has historically occurred. Regardless of challenges, we have to continue to strive toward that future of making space accessible to the world, and to see what's possible when you come together to overcome the biggest challenge of all, landing on the surface of the moon.
Astrobotic is among a pool of vendors that can bid on contracts for future NASA deliveries. This model will hopefully mean frequent, rapid, and affordable access to the moon.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
Flying on commercial missions will mean cost savings for NASA, as we've said, but this approach has risks. So to explain, I have Joel Kearns here. He's the Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate. Good morning, Joel.
Hi, good morning, Megan.
So talk to me about why we want commercial companies sending our science experiments. Why don't we send them ourselves?
Well, you know, NASA is really good at sending robotic science probes throughout the solar system, but it takes a lot of effort, it takes a lot of time. And for our big push to do science and technology on the moon as part of Artemis, we wanted to take a new approach. We wanted to tap into the new ideas, the entrepreneurial spirit, and all the engineering innovation that these small companies and startup companies bring in the United States. We think they can help make the overall moon effort much better.
But isn't it riskier for us to depend on others versus us doing it ourselves?
You know, there is a different level of risk that we all had to understand and agree to when we started down this. Like I said, we understand how to do robotic science missions at NASA, but we do know that these companies have a lot of good, interesting ideas. By partnering with several different companies for different lunar landing missions, we get to see all their individual strengths, their different technical approaches, but at the same time, we don't get the level of information and we don't have the level of control or direction that we're used to having at NASA. But we think that trade is really worth it.
But why is it so important for us to send science before we send astronauts? We didn't do that before with the Apollo program.
Well, it's been many decades since Apollo, and there were many, many unanswered scientific questions about the moon, not just about the moon itself, but how the moon is almost a time machine to look back to see what happened at Earth in the earliest ages of Earth. So, for example, we can do studies at the moon to try to determine when did all those last big meteor impacts take place? Because if we see them in the moon, they actually happened at the same time at Earth, maybe around the same time life was forming at Earth. You could also look at the moon, and we might be interested in using water ice that's at the south pole of the moon, we expect, for our astronauts in the future. But understanding how that ice got there, how that water got there in the first place, will help us understand how do we have water at Earth that we get to use today.
Real quick, is there anything in particular that you are most excited about discovering on the moon?
Oh, well, there's just so many things. There have been scientific questions for decades that people, scientists in the United States, around the world, have been dying to get back to the surface of the moon to do. We've sent many probes in orbit around the moon, like Lunar Reconnaissance Orbiter, but they look at it from afar. This is going to be our first chance to go back and really make those measurements and really touch the surface and see what's really there.
Joel, thank you so much. I know we have ambitious goals here at NASA. I can't wait to see what we do.
Oh, thank you. This is an exciting day.
Yes, thank you so much. All right, so let's head back over to ULA's Amanda Sterling for another update on the Vulcan rocket.
Things continue to go as planned as we look forward to the launch of ULA's first Vulcan rocket. We're still holding at T-minus 7 minutes as part of our planned 60-minute hold, and the team is not working any issues at this time. The Vulcan booster is fueled to flight level with super-chilled liquid oxygen and liquid methane. Soon, Centaur topping to flight levels will begin, and the ULA team is on track for an on-time liftoff at 2:18:38 a.m. Eastern. We're about 5 minutes away from Space Launch Delta 45's final weather briefing. At the moment, our weather continues to look good through the 45-minute launch window we have available this morning. The excitement is building here in ULA's Advanced Spaceflight Operations Center as we get closer to T0. Back to you, Megan.
All right, we're about 35 minutes away to the opening of today's launch window. Inside Vulcan's payload fairing is Astrobotic's Peregrine spacecraft. Astrobotic is based in Pittsburgh, Pennsylvania, where folks there are laser focused on Peregrine right now. Right, Olivia?
That is definitely right, Megan. I'm checking in on our Peregrine lunar lander with our mission control team right now. You can see them on screen. A reminder that our spacecraft is currently sitting in the top of ULA Vulcan's fairing. Our flight director is informing me that Peregrine is looking nominal with temperatures currently at an expected 70 degrees Fahrenheit. We also monitor the environmental pressures around the spacecraft, and we're sitting at a good 14.7 psi. Things are looking good for launch. The spacecraft is currently powered off, but will automatically power on once it separates from Vulcan's payload fairing. And here you can just see the faces of some of the engineers who have worked many hours on Peregrine to get it to the launch pad today. Sitting in the middle left row is Flight Director Anders Solorzano. He is the acting flight director for this launch. And nearby is Alex Van Hoven. He is currently providing us updates on the spacecraft status. And Alex just informed me that the spacecraft is currently looking nominal. Temperatures and pressures are still as expected. As we continue to await launch, let's send it back to Megan at the host desk.
Thank you, Olivia. Again, Peregrine is flying with 20 payloads today. 5 of those are NASA's, and throughout the show, we will tell you about each one, starting first with the Linear Energy Transfer Spectrometer, or LETS, from NASA's Johnson Space Center.
I'm Nick Stoffel. I'm a physicist and professional engineer, science and operations lead for the LETS payload. The Linear Energy Transfer Spectrometer is a small, low-power radiation detector based on Timepics technology developed at CERN. It's similar to devices that we've flown on ISS and Artemis. The science we're expecting to get from the LETS detector is take that information and translate it from deposited energy in silicon, which is what we measure with this detector, into a more biologically equivalent value that we can utilize for crew protection. One of the key pieces, I think, that if we can capture would be outstanding is getting data from a radiation event, a solar storm on the moon, while crew are not there. That would be ideal from the standpoint of being able to get the data without putting crew at risk, and then utilizing that data to prepare for crew protection during the lunar operations.
Now, NASA's Science Technology Mission Directorate had a hand in today's launch. So here with me now is Nikki Werkheiser, Director of Technology Maturation. Good morning to you.
Good morning.
So tell me how STMD, that's the shortened version of the directorate there, tell me how it invests in small business like Astrobotic.
Of course. So the Space Technology Mission Directorate, our mantra is technology drives exploration. So if you're really going to create new disruptive technologies that change the world, you really have to work with a diverse group of individuals. And that means our small businesses, large businesses, international partners, other government agencies. Astrobotic is a shining example of that. STMD has been working with them for well over a decade. We've awarded over 40 Small Business Innovation Research Awards and our tipping points to develop new technologies for the mission.
So is that essentially like seed money? Is that how to consider it?
Yes, we're partners, right? We're partners in this. We say at Artemis we're going together, and we mean it. We're invested hand in hand in this.
And how have those financial awards, how have those helped Astrobotic?
So, for example, not only do we have science and different payloads aboard the mission, but actually parts of the lander itself, like our navigation Doppler LiDAR that helps with the guidance, navigation, and control, terrain relative navigation that helps to make sure that they can land in safe spots. You know, the moon can be very treacherous. And also the axial thruster engines on the lander itself are brand new engines that have never been flown before that we're testing on the moon together.
How does it feel to see technologies that your directorate developed, you know, helping us get back to the moon?
There are not words. I really get goosebumps. And, you know, the funny thing is, if you'd asked me as it was a child, of course, it's the amazing engineering and science feats that we see happening. But as a child that was raised in a family of a small business, doing this together with small businesses, this being our NASA and going together to the moon, is really just incredible.
Yeah, just what do you think about that, again, that we're bringing in as many as we can with us back to the moon?
You know what I think? I think that means success. Yeah. I think it's going to require all of us and our mutual strengths to make it happen.
Thank you, Nikki. I really appreciate you being here, and I hope you see a beautiful launch today.
Me too. Let's go.
All right, we're just about under 31 minutes to the opening of today's 45-minute launch window. After Peregrine 1 today, Astrobotic will deliver another payload for us, and that's our Viper rover later this year. Right now, teams across NASA are busy working on Viper, another important lunar delivery. Viper is short for Volatiles Investigating Polar Exploration Rover. But what are volatiles, and why is NASA looking for them? Volatiles are substances that easily evaporate. And one of the most important volatiles NASA is trying to map on the moon is water. Water is critical for deep space exploration because you can drink it, but also turn it into oxygen for breathing and hydrogen for fuel. NASA has selected Astrobotic for Viper's lunar delivery under CLPS, or the Commercial Lunar Payload Services Initiative. And when Viper gets to the moon, it will search for ice on and under the lunar surface near the moon's south pole. About the size of a small car, it has a drill and 3 science instruments. Together, they will work to uncover how frozen water got on the moon in the first place and what has kept it preserved over billions of years. This mission will help NASA understand the environment where we plan to send astronauts as part of its Artemis program, which will establish a long-term presence on the moon and eventually Mars. That's your Artemis Moon Minute. Our next Artemis mission is Artemis 2, which will send 4 astronauts around the moon. And work is already well underway on the ride, NASA's Space Launch System rocket. Right now, teams here at Kennedy are processing segments of the 2 side boosters. Each booster will stand about 17 stories tall and burn approximately 6 tons of propellant every second, producing 3.6 million pounds of thrust. We continue to march towards today's 45-minute launch window that opens at 2:18 and 38 seconds Eastern Time. The ULA team remains in a planned hold and right now working no issues. As for the Peregrine spacecraft, let's get another check of it from Olivia with Astrobotic.
Thank you, Megan. As you may recall, we are currently only monitoring the spacecraft's temperature and pressure while it sits inside the Vulcan rocket's payload fairing. And we're checking in with my team members in Mission Control, and Alex Van Hoven, one of our flight directors in the very back row. He is providing us updates directly. Our mission team confirmed the spacecraft's levels are nominal, and we continue to be ready for launch. And I'd like to take this time to say a well-deserved shout out to the entire Astrobotic team in Pennsylvania, California, and even a few remote workers. I'm sure you're all watching right now, and we thank you for your continued commitment to this mission and to lunar exploration. We really, really couldn't have done it without you. Now, as we sit tight for launch, we'll continue to monitor Peregrine. For now, back to Megan at the host desk.
A few minutes ago, I told you about NASA's LETS payload flying on Peregrine today. Now we'll learn about NIRVIS, or the Near-Infrared Volatile Spectrometer System from NASA's Ames Research Center.
Hi, my name is Tony Colaprit. I'm the lead scientist for the Near-Infrared Volatile Spectrometer System, or NIRVIS. The NIRVIS instrument combines three observations. It has a spectrometer that tells us about the composition of the lunar soil. It has a high-resolution camera that tells us about the fine-scale structures of that soil. And it has a temperature measurement that tells us the temperature of the lunar regolith. NIRVIS combines all these three measurements to help us better understand the compounds that are on the surface of the moon. Particular compounds we're interested in are volatiles. A lunar volatile is a compound that is very sensitive to temperature. At low temperatures, it's solid. At high temperatures, it's a vapor. Water is a good example of a lunar volatile. We believe water is manufactured in sunlit regions of the moon, either through solar wind or through micrometeoroid impacts, and then migrates to the poles of the moon where it's captured into dark, permanently shadowed craters. If there is water at the poles of the moon in substantial quantities, that might be of incredible importance and use to human exploration going forward.
Now, we still have 3 more NASA payloads to tell you about flying on NASA's first commercial lunar payload services launch. But now we want to turn the broadcast over to ULA. Amanda Sterling will walk us through the rest of the Vulcan rocket's inaugural flight through launch and ascent. And then Olivia and I will be back around 15 minutes after liftoff to continue monitoring Peregrine. ULA will join us in just a few seconds.
Good morning. I'm Amanda Sterling, a program management leader and your host for ULA's live coverage of the inaugural Vulcan launch. I'm joining you from ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. Thanks for staying up late or getting up early with us for today's exciting first launch, Vulcan's Certification Flight 1, or Cert 1. This is the first of 2 planned test flights to support full certification of the Vulcan rocket for U.S. government missions. On board the Vulcan rocket today is Astrobotic's Peregrine commercial lunar lander on a mission to intercept the moon, and the Celestis Memorial Spaceflight payload Enterprise, flying to deep space with the Centaur upper stage. Liftoff is scheduled for 2:18:38 a.m. Eastern, and we have a 45-minute launch window this morning. In addition to watching our webcast, you can also follow the live mission progress at ulalaunch.com. About 30 minutes ago, the count entered a 60-minute planned hold. We have 2 planned holds in our launch count, which give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues, and we're proceeding towards an on-time liftoff. We're excited to partner with NASA on today's live broadcast. Together, we'll be continuing our coverage through end of mission. Building on more than 120 years of combined Atlas and Delta launch experience, ULA's Vulcan rocket introduces a balance of new technologies and innovative features to ensure a reliable and accessible space launch service. Let's hear more about this incredible launch vehicle from ULA Business Development Director Tom Burkholder and Vulcan Chief Engineer RJ Sansom.
So RJ, can you discuss a little bit of the when you began the design of Vulcan and what that meant?
Yeah, when we started the design of Vulcan, we were looking at our national security space customer and designing a launch system that would meet their needs. And we focused on being able to provide lift for the most difficult, stressing mission, which is a high-energy mission. We designed a launch system that's flexible. We have the ability to add solid rocket boosters, take them off, to tailor the performance that we need for that particular customer's mission. We have an extremely capable upper stage in the Centaur 5 that provides performance that exceeds all the capabilities that our customer needs. And in the end, we've got a launch system that exceeds all of our national security customers' requirements and enables us to provide performance for commercial customers or other customers that will meet their needs now and into the future.
That's great. And as we look at how the customer received that vision, we definitely saw that they were aligned with it as they contributed to the development from the Space Force to NASA and commercial customers. And so I was wondering if you could also talk on the partnerships that you had in the development.
Yeah, from the beginning, we partnered with industry partners who have expertise and capabilities to help us bring new innovative technologies, as well as to leverage existing technologies. So we brought a very capable yet new design forward that was a low-risk option. We partnered with Grumman on development of new rocket boosters. The first variant of that flew on Atlas with a tailored version that was tailored to provide specific performance for Vulcan. We partnered with Rocketdyne on development of RL-10 and implementation on that, again, first flight on Atlas and then flying again on Vulcan. Partnered with Beyond Gravity on composite structures. And then we partnered with Blue Origin to develop a new main stage propulsion system, the BE-4, the first Oxford stage combustion engine developed domestically. So, industry partners brought a lot to the table for us.
That's great. And then as we look at what this has meant to the market, it's been fantastic. And I was wondering if you could share with me how the Vulcan design has evolved as we've started to look at the commercial market with Project Kuiper.
Yeah, we had a really capable launch system to start with. And as we looked at the commercial market and the focus on LEO, we decided that a small change to our design, a small change to the upper stage would give us increased performance and ability to lift more spacecraft to the low Earth orbit and really position us well for supporting the Kuiper contract and our Kuiper customer.
Yeah, and the result of that was the largest launch contract ever. And so with that, Vulcan has positioned ULA to help support national security, NASA, and our commercial market. So we're very excited about the future. Go Vulcan, go Centaur, go Cert-1.
I'm now joined by ULA President and CEO Tori Bruno. Tori, thank you so much for joining us on this monumental day. I've been a part of the Vulcan team for a number of years, so I know how focused the whole ULA team has been. Can you talk a little bit about the teams that came together to design, build, and now launch this rocket?
I am so proud of our people, and I think we had exactly the best possible team. We've got folks that designed rockets before, like Atlas and Delta, but we also have the majority of our team, people like yourself, that are earlier in their career, know the new tools, aren't sort of handcuffed by some of the conventions that we used before, and can do really creative and innovative work while also not making the mistakes of the past.
Absolutely, and Vulcan is such a unique rocket. What are you most proud of about this vehicle?
I'm really proud of the fact that we still service the high energy marketplace, a unique thing that is really important to our nation's security, that no one else has an architecture that will do that, while at the same time breaking all the rules and having the dial-a-rocket architecture that gives it the flexibility to reach down into that LEO marketplace and be very competitive there as well.
Absolutely. So we're getting pretty close to liftoff now. How do you expect to feel watching the Vulcan rocket lift off for the first time?
tremendous excitement and anticipation. I got to tell you, I've done over 400 launches. They're all the same. I always get butterflies. This one's really special because of what it means to our country, to our customers, and to the team that has worked so hard, including you, Agent Sterling.
Well, thank you so much for joining us. We'll let you get back to it so you can make sure you watch liftoff, and let's go.
Go Vulcan. Thank you.
On board the Vulcan rocket today is Astrobotic's Peregrine commercial lunar lander. Peregrine is the first spacecraft in NASA's new CLIPS initiative to have American companies send its science experiments to the moon.
Astrobotic is a full-service lunar company. It starts with our terrestrial testing and development services that can build and test propulsion systems on Earth, to the sensors that make precision landing possible, to our rovers that will deploy down on the surface of the moon. The big thing that we're known for is our 2 lunar missions to go to the surface of the moon. Our first one is about to launch, and our second one flies in 2024. The Peregrine mission is important because it's among the first commercial missions to return to the surface of the moon. This is the dawn of a new era of affordable, routine, regular access to the surface.
Peregrine's development was a years-long process that included many people, like engineers, welders, and technicians, who designed and built the spacecraft.
To be on the pad today with our spacecraft strapped to a giant 200-foot-tall launch vehicle, it's a little surreal. It's a moment I've been dreaming about, and this first mission is just our first step to make space accessible to the world, and it certainly will not be our last.
Line item 911 has been disabled. Roger.
Also riding atop today's Vulcan rocket is the Celestis Memorial Spaceflight payload. Let's learn more about this mission.
Celestis' Enterprise flight carries capsules containing cremated remains, DNA samples, and greetings from Celestis' clients worldwide. The capsules are integrated into 2 carriers that are mounted to the forward adapter on ULA's Centaur upper stage. The carriers will remain affixed to ULA's Centaur as it travels into a heliocentric orbit around the Sun, where it will remain for eternity. The Enterprise flight is Celestis' first deep space mission.
Flight Control, LC.
Go ahead, this flight control.
Reduce Vulcan hydraulics to standby.
Roger.
Today's rocket includes the American flag across the inner stage, as well as logos on the payload fairing representing ULA, Vulcan, and Astrobotic. While this is the inaugural launch of the Vulcan rocket, the CERT-1 flight test marks ULA's 159th launch. Let's learn more about this innovative new rocket.
Designed by ULA's engineering team and built by our skilled technicians, the Vulcan rocket, once fully stacked, stands 202 feet and weighs nearly 1.5 million pounds fully fueled. Vulcan's first stage is built using lightweight, machined and bump-pressed orthogrid aluminum panels to form the liquid propellant tanks. Once formed, tanks are joined together using circumferential friction stir welding before heading to the paint booth. Prior to mating to the booster, the BE-4 engines are individually hot-fired. At the base of the rocket is the Vulcan booster, powered by twin BE-4 engines. For additional thrust at liftoff, solid rocket boosters, or SRBs, are attached to the rocket. Atop the booster is ULA's ultra-thin stainless steel Centaur upper stage, powered by 2 RL-10C engines. Spacecraft are encapsulated inside a protected 5.4-meter diameter payload fairing. With production complete, the rocket travels from the ULA factory in Alabama to the launch site in Cape Canaveral on ULA's rocket ship. Once in Florida, ULA's launch operations team begins a series of events leading to today's countdown. The process begins by lifting the 109-foot booster onto the newly constructed Vulcan Launch Platform, or VLP. For missions requiring additional thrust at liftoff, SRBs are attached to the side of the booster. Then, following interstage mate, the Centaur upper stage is transported to the VIF and lifted into position. Lastly, the encapsulated payload fairing is lifted and mated to the Vulcan rocket. Once fully assembled, the launch countdown begins, with moving the rocket from the VIF to the pad. Riding atop the VLP, Vulcan's trip to the pad is about 1/3 of a mile. Weighing in at approximately 2 million pounds, the VLP supports the rocket and contains air conditioning, electrical, and commodities lines. Throughout the 20-minute trip, a support van leads the move, followed by the payload van, providing communication with the spacecraft, while the ground van provides support to the rocket. Track mobiles at the rear power the nearly 3 million pound convoy, which also includes an environmental control system, providing air conditioning to the payload and rocket, as well as a backup generator. With the rocket on the pad, the launch team transitions to fueling and other final preparations.
Launch. Maintain operational silence in the LCC.
Go, LOX 2.
Center LO2 at flight level.
Roger. Terminal count briefing. If a condition exceeds a launch constraint, anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold. RLM, verify redline monitor and event table on the correct configuration for terminal count.
Verified.
As we approach the terminal count pole, let's check in on today's weather. The Space Launch Delta 45 forecast for this morning's launch is looking good. The probability of violating launch constraints is 15%. Ground winds are 15 to 20 knots out of the north, and the temperature is 57 degrees Fahrenheit. The primary concern for launch is the thick cloud layers rule.
L minus 11 minutes.
We remain in the planned 60-minute hold as we continue towards liftoff. In a few moments, launch conductor Dylan Rice will poll the launch team for the final go to pick up the count. 29 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling.
Prior to the status check.
L minus 10 minutes.
Status check to proceed with terminal count, Vulcan systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LNG.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cubed.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC. Verify T0 is set for 071838 Zulu.
Verified.
Polling is complete and the team is go for launch. From T-minus 7 minutes until liftoff, you'll hear Dylan Rice and the team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur, and arming the flight termination system. At T-minus 1 minute, the Range Operations Commander confirms the range is in a green condition for launch. At T-minus 25 seconds, you'll hear "Go Vulcan," "Go Centaur," "Go Peregrine." This is the final status check of rocket and payload readiness. At T-minus 7 seconds, ROFI sparklers will ignite, followed a second later by initiation of the launch pad water deluge system. At T-minus 3 seconds, the main engines ignite. Then, after seeing Vulcan's first ever liftoff from Slick 41, you'll begin hearing flight commentator Rob Gannon providing launch vehicle ascent data. This is Vulcan Mission Control at T-minus 7 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 7 minutes and counting. 3, 2, 1, mark. 6:55. Ground pyros enabled.
The countdown clock has resumed, and we are go for launch at 2:18:38 a.m. Eastern. After liftoff, ULA's Vulcan rocket will head east from Space Launch Complex 41. Here's a look at today's ascent.
Following final confirmation of rocket and payload readiness, 2 GEM 63XL solid rocket boosters and twin BE-4 engines produce more than 1.7 million pounds of thrust to lift ULA's Vulcan rocket away from Cape Canaveral Space Launch Complex 41. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Vulcan then reaches Mach 1, the speed of sound. With the ability to add 2, 4, or 6 solid rocket boosters, or SRBs, Vulcan can be precisely configured to take any mission to space, from low Earth orbit to Pluto and beyond. These boosters augment the rocket's total thrust at liftoff, adding approximately 460,000 pounds of thrust per SRB. With their propellant expired approximately 90 seconds into ascent, the SRBs burn out, followed by jettison. Jettison time is variable, occurring between 100 and 150 seconds after liftoff, depending on mission requirements. Vulcan's guidance system then activates to steer towards the precise target in space. First stage flight continues as the rocket crosses the Kármán line, entering space. With the majority of propellant expended as Vulcan fights against the force of gravity, the BE-4 engines shut down, and the booster stage separates. With the rocket now weighing less than 10% of what it did at liftoff, dual RL-10C engines on ULA's Centaur upper stage ignite. Spacecraft are encapsulated inside a 5.4-meter diameter payload fairing, which provides a protective environment during ascent. Following Centaur engine ignition, the payload fairing is jettisoned. With the first burn complete, the Centaur engine shuts down for a coast phase. Centaur flies a short, medium, or long coast, which is determined by launch day. Further into flight, Centaur ignites for a second burn, powering the vehicle into a translunar injection orbit. Following the second main engine cutoff, ULA Centaur places Astrobotic's Peregrine lunar lander into a highly elliptical orbit, more than 220,000 miles above Earth, where it will intercept the Moon. Following delivery of the Peregrine spacecraft, Centaur comes alive for a third and final burn to reach a heliocentric orbit around the Sun. Centaur completes the CERT-1 mission by carrying Celestis' Memorial spaceflight payload into deep space. Known as the Enterprise flight, This mission includes 234 flight capsules containing cremated remains, DNA samples, and messages of greetings from clients worldwide on an endless journey in interplanetary space beyond the Earth-Moon system to orbit the Sun forever.
$249.
STS internal.
$238. $230.
CLO2 PLP started.
$159.
Vehicle internal.
T-minus 2
155.
minutes. The launch vehicle, payload, ground systems, and Eastern Range are go for launch. For those of you just joining, I'm Amanda Sterling, and I'm your host for today's live coverage of the inaugural Vulcan rocket launch. The team is not working any issues, and we're on track for an on-time liftoff at 2:18:38 a.m. Eastern Time.
STS armed.
$120.
SCS count started.
One minute.
T-minus 1
Report
minute.
range status.
Range green.
$45.
Vulcan tanks at step 3.
$30.
BE4 start box, go.
Status check.
Go Vulcan.
Go Centaur.
Go Peregrine.
15. 10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. And liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
Engines operating. 2 good SRBs, hitting peak pressure on the SRBs. Everything looking good. And we've got pitching out programs in, coming into normal rates for that event. We have good hydraulic pressure on both engines. Good chamber pressure on both engines, everything looking good. Coming up on 60 seconds into the flight, everything looking good. 2 good engines, 2 good SRBs. Body rates look good, nice and smooth. And we've hit our first throttle point on the BE4s, everything looking good. And we We have passed through Mach 1. We are now supersonic, coming up on max Q. We've had max dynamic pressure. Everything looking good. We're rolling off on the SRBs. And we have cutoff on the SRBs, coming up on jettison in approximately 30 seconds. "15 seconds to SRB jet. BE4s continue to operate nominally. Seeing expected PU activity on the booster mains. And we have separation of both SRBs. Everything looking good. BE4s continue to operate normally. Coming up on 2 minutes into the mission. We are now 17 miles in altitude.
We just heard confirmation of solid rocket booster jettison. We have about 3 minutes until we reach our next mission event, booster engine cutoff.
And we see booster PU correcting towards a nominal MR. Everything looking good. Both engines continue to burn normally. And we now weigh approximately half of our liftoff weight. Everything looking good. And we fired the power valve, activating the reaction control system on the upper stage. Pressures are rising as expected. PE4 continues to operate normally. Vehicles continue to fly down the center of the range track. Everything looking good. 33 miles in altitude, 52 miles downrange, traveling at 4,000 miles per hour. Continue to see excellent performance out of the BE4s. Chamber pressure nice and smooth. Vehicle steadily accelerating, a little over 2 Gs at this time. Good body rates. Nice and smooth operation of the booster. 47 miles in altitude, 95 miles downrange at 5,500 miles per hour. Engines continue to burn normally. Everything looking good. And the vehicle now weighs 1/4 of its liftoff weight as we pass through the Kármán line. Next mark event we're looking for is boost phase chill down on the Centaur main engines. Booster mains continue to operate normally. And we've begun boost phase chill. Housing temps are dropping as expected. Coming up to the end of boost phase, approximately 10 seconds to BECO. Throttle down in preparation for BECO. We've completed boost phase chill down, and we have cutoff. Coming up on Vulcan Centaur separation. We have Vulcan Centaur separation. Everything looking good. Coming up on the Centaur phase. And experiencing a bit of data loss here. We've recovered the data. It's like Centaur engines are up and running normally, good steady state pressure, and we've just jettisoned the payload fairing. 2 good brake wires. And good steady state operating levels on the Centaur mains. 2 good engines. Gone to open loop control on Centaur PU.
This is Vulcan Mission Control at T plus 5 minutes 57 seconds. We just heard flight commentator Rob Gannon confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, main engine cutoff, will occur in about 10 minutes. While we wait, I'm joined by Amanda Bicchetti, ULA Director of Vehicle Upgrades. Amanda, thank you so much for joining us, and I know it's still early, but congratulations.
Thank you. You as well. This is amazing.
How did it feel to watch the Vulcan rocket lift off for the first time?
Oh, just absolutely amazing. I didn't expect it to be the way it was. It just, my heart is still pounding. It was excellent, and just I'm so proud of all the work that the team did to get where we are today.
Absolutely, and developing a new rocket is an enormous endeavor of which you were a huge part. Again, we're still early, but how do you imagine the whole Vulcan team is feeling right now?
I feel like they have to be the same way, you know, smile ear to ear. I know the team is at all our sites, friends and family. They've been supporting us for many years to get to where we are, so I'm sure they are jumping up and down just like me. It's been amazing.
How is the Vulcan rocket going to change the industry?
Yeah, that's a great question. So Vulcan is very much based on our heritage rockets, the Delta IV and Atlas V vehicles, but we've brought in a lot of new innovation and capabilities that are going to allow us to even better support our warfighters, exploration, as well as connecting the world. And the great thing about Vulcan is it's highly versatile, meaning we can use that vehicle to do anything we want, allows for affordability for anybody who needs access to space.
Absolutely. And so this is the first certification flight. What are the next steps for Vulcan after this?
Yeah, so with the first flight, we are well under the way from a certification perspective. We do have a second flight that we'll need to do here later this year. Once that completed, we'll have about 2 months or so of post-flight data testing, and then at that point we will be certified by the U.S. Space Force, and we will be ready to fly all of their important payloads for them.
Awesome. Well, again, thank you so much for joining us, and we'll let you get back and watch the next mission
Excellent.
events.
Congratulations again.
Thanks, you too.
Coming up on 500 seconds into the mission, everything's looking good. Continuing to burn Centaur. Body rates right as expected. Steady acceleration, just under half a G. And we are now 235 miles in altitude, 836 miles downrange, traveling at 11,150 miles per hour. Continue to see nominal performance from Centaur. And approaching the halfway point of this first burn of Centaur, everything looks good. We're now 1,000 miles downrange, traveling at 11,500 miles per hour.
This is Vulcan Mission Control at T plus 10 minutes 7 seconds. Our next event, main engine cutoff, will occur in about 5 minutes. While we wait, I'm joined by Eric Monda, part of ULA's mission design team. Eric, thanks for joining us.
Hi, Amanda. Thank you for having me.
Of course. So we're still pretty early in this flight today, but can you tell us how the data's looking so far?
Yeah, absolutely. So I just want to say that it was so exciting. I ran outside so I could watch this thing lift off, and that was so cool after so many years of development to watch this thing fly. That was fantastic.
Absolutely, I bet.
Yeah.
So what is the data showing us so far?
Yeah, absolutely. So I've had a very quick look. Obviously, we're very early in the flight still, but I've taken a look at the SRB performance as well as the booster performance so far, and everything looks just spot on, just perfect. Fortunately, we've had a lot of these systems on Atlas and Delta for a long time, and so we've had a lot of flight data to anchor our models, and everything is lining up just like we would expect.
Awesome.
Yeah.
So a lot of the audience has seen us switch from this live view of the launch from our rocket cam to this animated representation of the vehicle in space. Can you talk a little bit about why we make that switch and how this visual is populated?
Yeah, absolutely. So when we first lift off, we have a feed directly from the cameras that are on the rocket back to the launch site here. And so with that, we can get the video feed that we need in order to provide those images. As we get further downrange and we go over the horizon, we no longer have that direct link. And so we rely on NASA's TDRS system to send telemetry from the vehicle back down to us on the ground. In that telemetry data, we get information like position and attitude and velocity. And so we use that to drive the animations you see here.
Okay, so we're looking at real data, what's happening. It's just a graphic of it instead of the real thing.
That's exactly right, yes.
Awesome, that's really cool. So, you know, today right now we're in the first of 3 Centaur burns. Can you talk a little bit about why we need 3 burns and how we use those 3 burns to complete our mission today?
Yeah, absolutely. So the first burn performs our injection into low Earth orbit. Unfortunately, if we just continue that burn from that point in time, we wouldn't necessarily be aligned with where we need to be in order to get to the moon. So what we do after we get to low Earth orbit is we shut those engines down, we coast around until we get to the right spot to do that, and then we light those engines up again. When we do that and complete that burn, that will allow us to send the Astrobotic Peregrine lander onto the moon. So we shut those engines down again. We are ready to do that, and then start them up one more time in order to do the third burn. And that's what's going to take Celestis's Enterprise mission out to deep space. So let's talk a little bit about where these things happen. We're going to go ahead and shut down the main engines on the Centaur when we get about halfway across the Atlantic Ocean. And then we're going to coast the rest of the way across the Atlantic Ocean, across Africa, and go ahead and start the engines up again when we get to Madagascar. And that's where we'll do the second burn. And then we coast again until we get about to Papua New Guinea. And when we get over Papua New Guinea, that's where we'll go ahead and do that third and final burn.
Okay, so you mentioned a couple of these key milestones that are ahead of us. What can everyone expect to see as far as the timeline of these mission events as they continue watching today?
Yeah, absolutely. So looking at the clock right now, looks like we've got about 2 minutes, a little over 2 minutes left here in the first burn of the upper stage. We're going to coast for about 30 minutes after that as we do that coast across the Atlantic Ocean and across Africa. The second burn will be about 4 minutes long, and then we'll have another coast for 30 minutes before we have a pretty short, like 20-second burn for the final burn. Once we've done that, then we've got some engineering demos we're going to do before we finally safe the stage and shut everything off. And then about 4 days later is when the Centaur will leave the Earth-Moon system and be off on its way to deep space.
Awesome. Well, thank you so much for sharing that with us, and thanks for joining us today. And we'll let you get back to watching those next events.
Absolutely. Thanks so much, Amanda.
Thanks.
PU system is steadily making the correction down to a nominal MR. Or 1 minute, D'Amico. Both engines firing normally.
This is Vulcan Mission Control at T plus 15 minutes 30 seconds. We are approaching the first main engine cutoff. Let's listen in.
Coming up on MECO 1. On to open loop control on MECO. We have cutoff. Both engines show normal shutdown signatures. We have settling established. 85% duty cycle. We are now in a 27-minute, 51-second coast duration to second burn of Centaur.
This is Vulcan Mission Control at T plus 16 minutes 20 seconds. We just heard flight commentator Rob Gannon confirm successful cutoff of the first main engine, and all systems continue to operate nominally. Our next event, Main Engine Start 2, will occur in about 27 minutes. At this time, we'll pass the broadcast back to the NASA team to continue with mission coverage through the coast phase. We'll join you back in as we approach the separation of the Peregrine spacecraft. Over to you, Megan.
Thank you, Amanda. Congratulations to you and the ULA team so far. If you're just joining us, welcome to the Space Coast of Florida, where we just witnessed the first launch of NASA's CLIPS initiative. It was a magnificent sight. Leaves me speechless, apparently. Just really lighting up the night sky and loud enough to set off a couple of car alarms nearby. CLIPS is short for Commercial Lunar Payload Services. It's a new model in which NASA contracts space on commercial missions to send science experiments to the moon ahead of us landing astronauts there. For today's launch, NASA selected Astrobotic to deliver its 5 lunar instruments. This is the first mission for its Peregrine spacecraft. Today was also the first launch of ULA's new Vulcan rocket. Again, congrats. It lifted off from Cape Canaveral Space Force Station's Launch Pad 41. Our broadcast here on NASA TV will continue through Peregrine acquisition of signal, which is expected to happen at the earliest around 3:17 a.m. Eastern Time. With me now is Sandra Connolly. She's the Deputy Associate Administrator of NASA's Science Mission Directorate. Good morning, and thanks for being here, Sandra.
Good morning. It's a thrill to be here.
Yeah, what did you think of the launch?
It was amazing. Yet another beautiful ULA launch. Totally spectacular, and it's super exciting to know that now our Peregrine 1 lander is on its way to the moon, and in about 2.5 weeks it's going to go into orbit. And a few weeks later from that, in mid to late February, we're going to actually see it land. And that will be the first, well, actually it'll be one of the early landings on the moon since Apollo, over 50 years, which is pretty amazing when you think about it. U.S. landings on the moon.
Yeah, it is. And the CLIPS is new as well. So talk to us a little bit about this program. We're using commercial companies to send science instruments to the moon for us. Why is that?
Yeah, I'm really excited about this program. It is a game-changing program for us. It really is leveraging industry in new ways. As you've probably seen, I mean, the whole aerospace industry has evolved over this last decade in amazing ways, and I think this is just yet one more step in doing so. So our commercial partners are actually delivering a service. They're delivering our payloads and other organizational payloads, whether it's other companies, whether it's international partners. Basically, anybody who wants to procure the service can deliver a payload to the moon using the CLIPS program.
And so there are 20 payloads flying on the Peregrine spacecraft right now. 5 of those are NASA's. Can you tell me a little bit about what they'll be studying once they get to the moon?
Yeah, so again, amazing service. So our payloads are going to be studying things, including understanding, studying water, studying the volatiles or the resources on the moon, studying the atmosphere, and also the radiation environment to help inform us for the future when we have humans back on the moon.
Sandra, thank you so much. I'm excited to see what we do with this initiative and this launch here today.
Thank you so much, and let me just say, go Vulcan and go Peregrine 1.
Yes, you can totally say that. Thank you so much.
Thank you.
All right, so when Peregrine lands on the near side of the moon on February 23rd, it will be one of the first lunar landings for the U.S. since the final Apollo mission over 50 years ago. Let's head back over to Astrobotic's Olivia Chapla.
Thanks, Megan, and what a great day so far. So for those of you just tuning in, I wanted to reintroduce myself. I'm Olivia Chapla, Director of Marketing and Communications for Astrobotic. Astrobotic is a space company with our primary headquarters in Pittsburgh, Pennsylvania, and we've just watched our Peregrine lunar lander rocket into space aboard a United Launch Alliance Vulcan rocket. This Peregrine spacecraft's mission is to carry 20 payloads or cargo to the lunar surface from 7 different countries. 6 of those nations have never reached the moon before. Our aim is to autonomously land on the lunar surface a few weeks from now. We're taking the long way around, and we expect Peregrine to land on February 23rd, 2024. We've got all eyes on the Peregrine lander as it waits to separate from the Vulcan rocket in about 30 minutes. At that point, we will seek to establish communications with the lander. And now we'll take a more in-depth look at Peregrine's full journey to the moon with an animation. Once ULA's Vulcan rocket launches, we will then know the exact day the Peregrine spacecraft will attempt a soft landing on the moon. The first landing attempt could be anywhere from 10 to 60 days from launch. Because this is Peregrine's first ever trip to the moon, our team is not taking a direct path. Peregrine will first complete one Earth orbit so the team can get critical data on the spacecraft and test maneuvers before executing a very critical milestone, entering lunar orbit. Peregrine will orbit the moon at 3 altitudes. The first orbit will last about 33 hours. Peregrine's second orbit can be up to 35 days. The spacecraft's third and final orbit around the moon will last 48 hours. Next up, Peregrine will attempt a soft landing on the lunar surface autonomously. The team will issue a landing sequence that will command the spacecraft to enter a descent orbit. About 15 kilometers from the lunar surface, an exciting powered descent begins. While we wait for the Peregrine spacecraft to separate from the Vulcan rocket and begin that exciting journey to the moon, I have Astrobotic's founder and Chief Executive Officer, John Thornton. Hi there, John. I understand you are currently at ULA, just a stone's throw from where I am now, and we both just saw ULA's Vulcan rocket achieve liftoff with our very own Peregrine aboard. Tell me, after waiting for this moment for years, how are you feeling?
It's a dream. This is the moment we've been waiting for 16 years, and I'm standing in mission control, and we just had a beautiful launch. Thank you, ULA. So excited. We are on our way to the moon.
I can tell you and everyone else are in a really excited buzz today for sure. So tell me, what else do you think is the most important thing about our Peregrine mission today?
So this is the beginning of the dawn of a new era for the surface of the moon and how we think about space. This is an opportunity for commercial payloads to fly to the surface of the moon on a regular, routine basis. That means our nation's scientists, our world scientists, can access the moon in ways never before possible. And we are seeing the beginnings of that right now as we speak on our journey to the surface of the moon. Our first mission carries 20 payloads from all over the world. 6 nations on board the mission will touch the surface of the moon for the very first time. It's a phenomenal, exciting mission to be a part of, and it's a real honor to be here today, and I could not imagine a better start to the mission.
That's true. And what do you have to say to the Astrobotic team and to all of the payload customers who made today's mission possible?
For 16 years, we've been pushing for this moment today. And along the way, we had a lot of hard challenges that we had to overcome, and a lot of people doubted us along the way. But our team and the people that supported us believed in the mission, and they created this beautiful moment that we're seeing today, working incredibly hard to make this possible. I can't thank the thousands of people between our team, our suppliers, our partners that have made this moment possible today. It's an unbelievable feat, and it is the culmination of all of everyone's effort coming together for this moment, believing in this possibility that a small company in Pittsburgh, of all places in this country, can lead America back to the surface of the moon.
Thank you, John. Well, I'll let you get back to the team that are in Florida with us as we wait for the Peregrine spacecraft to separate from Vulcan's rocket in about 30 to 40 minutes. For now, back to Megan.
Thanks, Olivia.
Oh, thank you.
Now, CLPS missions are an important step in returning to and staying on the moon. But these lunar landings that will help shape our future there are not without risks.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science exploration and technology experiments as possible.
So CLPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLIPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely.
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission, and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLIPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
And a lot has to happen before Peregrine lands safely on the moon. Astrobotic's Olivia Chapla shows how they tested the spacecraft here on Earth and what the team will do during its journey in space.
Peregrine has gone through quite a journey already and still has a long list of objectives to complete on its way to the moon. We've categorized these objectives into 5 stages, beginning with engineering it here on Earth. First, we built and tested a bolt-for-bolt engineering model of Peregrine. Based on our findings, we constructed the final spacecraft to send to the moon. Each iteration of Peregrine went through rigorous testing to ensure it will survive the harsh conditions of launch and space environments. Phase 2 objectives will begin when the spacecraft separates from the rocket. Once separated, Peregrine will power on and establish communications with Earth. At this stage, we'll receive telemetry informing us of the spacecraft's position, orientation, and general operational health. One of the first commands we send to the spacecraft will initiate thrusters to point Peregrine's solar panels at the sun to charge its battery. We are planning for all of these objectives to be completed today. Next, and off-camera, our Phase 3 objectives begin. These objectives include trajectory adjustment maneuvers in space before lunar orbit insertion. After lunar insertion, Peregrine will complete 3 orbits around the moon. Then, the last phase of the mission begins, lunar landing and operations.
And for a closer look at landing, I'm joined now by Mike Hennessy, Educational Director of the Moonshot Museum in Pittsburgh. Good morning to you.
Good morning. It's spectacular to be here today.
Absolutely. We saw a launch, right?
Yeah, and it was awesome.
Yeah, absolutely. So talk to me about Peregrine and the spacecraft we have you on, because you know a lot about Peregrine and this mission. Why is that?
Well, every day I've had a front row seat at Peregrine under construction. I work at the Moonshot Museum, and we share a wall of windows with Astrobotic. And better yet, I've seen kids with their faces pressed against the glass, knowing they're going to grow up to become that next generation of makers that take us to the moon.
That's fantastic. And you also brought us some props here. So these are different parts, different materials that make up the multi-layer insulation. That's what goes around the spacecraft, right?
Right. That's the thermal protective space blanket for the craft. spacecraft, and we have a number of different materials here. This is Astro Quartz. It's a woven ceramic fiber, very heat resistant. We've got aluminum, which is great for reflecting solar heat. And this is also aluminum. Glitters a little more like gold, but it's just aluminum that's been covered with a polymer called Kapton. And you can see it actually on our model here. We have of the Peregrine lander.
Right here. This is the multi-layer insulation.
Yeah, we've got
we're
the multi-layer insulation, and that's wrapping these fuel tanks, kind of like cosmic baked potatoes.
And why do we need all these different materials?
Well, the moon is a harsh environment, and it takes a lot of technical know-how to land there. There's no atmospheric blanket like we have on Earth. So we need a thermal space blanket to protect against wild temperature extremes. Boiling hot days, freezing cold nights, several hundred degrees below zero, and Peregrine's been engineered to endure that.
Okay, so now we know how it will be protected during landing. How will it land? What technologies are we using to make sure that it lands safely when you say that the moon isn't the easiest place to land on?
Right, and that's my favorite part of the story because this robot is going to land itself. Because we have about a 2.5 second signal delay from the Earth to the moon and back, it's like having a self-driving car going to another world. We have a full suite of sensors, gyroscopes, Doppler, LiDAR, star trackers, and a really cool technology called Terrain Relative Navigation, or TRN. About 9 miles out, Peregrine will activate its camera, and as it's descending, and the camera is taking pictures, the computer will be playing kind of a high-speed game of flashcards. Comparing those pictures to 3D maps, and then Peregrine will have to make decisions in order to come to a landing. We're going to test drive this technology on Peregrine, and then on Astrobotic's next lunar lander, Griffin, TRN will be in the driver's seat when we head to the moon's south pole.
Oh, that's fantastic. And I know Griffin is going to be delivering another NASA payload, so another partnership where we get to do this together.
Yeah, I think another great example of how CLIPS is bringing together entrepreneurship and accelerating the pace of science and taking us out into the solar system.
Mike, thank you so much. Thank you for being here.
Thank you.
All right, so the Astrobotic team hopes to land on the near side of the moon on February 23rd in a place called the Bay of Stickiness, a lunar feature formed by ancient hardened lava flow. It's located outside of the Gruithuisen domes, which is the largest dark spot on the moon. Why does NASA want to conduct science here? Well, on Earth, formations like these domes need significant water and also plate tectonics to form. But without these key elements on the moon, lunar scientists have been left to wonder how the domes formed and evolved over time. We'll of course have coverage of the landing on our NASA Plus app or whichever social platform you watch us on. Now, earlier in the show, we told you about the NERVIS payload from NASA's Ames Research Center. The other payload from Ames is the Neutron Spectrometer System, or NSS.
I'm Rick Elphick. I'm the principal investigator of the Neutron Spectrometer System aboard the Peregrine 1 lander. NSS measures neutrons coming out of the lunar soil, and the neutrons tell you a lot about the makeup of the lunar soil. The neutrons that we measure with the neutron spectrometer are specifically related to the presence of hydrogen, the H in H2O, or water, and that's its real purpose, is to locate water, to actually act as a divining rod. Peregrine will be landing in a location where we really don't expect very much water, if any at all. But it's an interesting experiment. The exhaust system of its descent engines will actually spray paint the surface with its exhaust. And part of that exhaust is water, and some of that water is actually going to stick onto the surface of the moon. Then after we land, NSS can monitor how that water goes away as the sun rises at the landing site and the day gets warmer and warmer. Water is really important as a resource for exploration. Astronauts need it for drinking water, but you can also use it by splitting it up into hydrogen and oxygen as rocket fuel. So if you can find water in place where you're going to, that means you can use it there and not have to bring it up from Earth.
Now, NASA has 2 more payloads flying to the moon today. We're going to tell you about both of them in just a few minutes. But first, let's introduce you all to Chris Culbert, Program Manager for CLIPS out of NASA's Johnson Space Center. Good morning to you.
Good morning, Megan. Thank you. It's a wonderful day.
It is. We just watched the launch. What did you think?
It was amazing. Oh, my God. What a wonderful feeling. That rocket was gorgeous.
Yeah, and so NASA has 5 payloads hitching a ride. Tell me about the different things that they'll be studying and why they're studying those things.
So, this early mission for CLIPS, this is our first mission. So our first 2 early missions are mostly carrying small instruments that help us learn more about the environment of the moon. As we get further into CLPS in future missions, we'll raise the complexity and start studying more complex, more difficult questions. But at the beginning, we're mostly trying to characterize what the moon is like, what the radiation does, what kind of environment we can find there. It doesn't have an atmosphere, but there's particles and dust and other things. We're trying to get more information about that so that we can help guide future human missions more effectively.
And how soon could we see data from some of those instruments so that we can start creating that fuller picture?
We'll start getting data back within hours of landing on the moon.
Wow.
Now, the scientists will need some time to analyze that information and turn it into the kind of information that helps guide future missions. But we should be getting data back from the moon within a few hours of landing, and we'll all the way for as long as 14 days on the moon. We'll be gathering that data. But the scientists will then take that information offline and analyze it for a while.
So basically these missions, these instruments that we're sending, they're scouting the moon for us.
Yes, yeah, they're telling us what the moon is like, helping us understand what we need to know so that we can take humans there safely. It also allows us to better design future instruments and other experiments that will pinpoint the kinds of things we need to know about the moon to be able to work and live there.
Chris, thank you so much. Thank you for being here.
You're welcome.
Okay, so we're now less than a few minutes away until the Peregrine spacecraft separates from Vulcan's Centaur upper stage. We're going to go back to ULA for that milestone, but before that, another quick status update on Peregrine from Olivia.
Thanks, Megan. And now I'm checking in on Astrobotic's mission control team. In about 20 to 30 minutes, they're expecting Peregrine to power on and then try to communicate with them on the ground. Peregrine will establish ground communications with NASA's Deep Space Network, and then we will begin receiving telemetry. As we wait for those milestones, here's an in-depth look at the inner workings of the Peregrine lunar lander.
And now we'll take a look at the Peregrine spacecraft. You'll notice that we've removed the MLI or multi-layer insulation so we can better see the inside of the spacecraft. Throughout Peregrine's journey, they'll keep an eye on the spacecraft's temperatures, pressures, power levels, and communications system. Solar panels at the top of Peregrine charge its batteries to power the spacecraft. Moving down towards the center of the spacecraft are the payload decks. You'll notice the decks have a unique isogrid pattern that we've used as an inspiration for a lot of our graphic design for the mission. This structure pattern optimizes the sturdiness of the payload decks while also minimizing its weight. Affixed to these decks are all 20 payloads. 20 individual pieces of cargo from 7 different countries are aboard these 2 main decks. Peregrine has 12 attitude control system engines, called thrusters, that are used to orient the spacecraft. You can see 4 large propellant tanks filled with monomethylhydrazine and multiple mixtures of oxygen-nitrogen, or MON, as oxidizer. Mounted to the bottom of the spacecraft are 5 main engines that will slow the craft down as it approaches the lunar surface. These engines use a hypergolic bipropellant pressure-fed system. Believe it or not, Peregrine will use the majority of its fuel in the last 15 minutes of the mission as we attempt a soft landing on the lunar surface. Peregrine has 4 landing legs attached to its base. These legs have a honeycomb structure on the inside that will crush to absorb the impact of Peregrine landing on the lunar surface. Peregrine is designed for an autonomous landing. That means it will use complex computing and a suite of sensors instead of human pilots. There are 2 antenna relays and a high-power transponder to relay communications between the spacecraft and the Astrobotic team. The relay will connect Peregrine with NASA's Deep Space Network, or DSN, utilizing the same dishes that communicate with the James Webb Space Telescope as well as other historic missions.
And the last major feature of Peregrine is something you can't see. It's the hundreds of people who have worked on, tested, and gotten the spacecraft to the launch pad today. A shout out to the team we like calling the Astrobots, and a shout out to our payload customers who are sending their items to the moon with us. Your continued commitment to science and lunar exploration is important for humanity. The Peregrine lunar lander has 20 pieces of cargo called payloads aboard. You can find the full manifest on Astrobotic's website, but here is a look at a few of the payloads. IRIS rover. This is a student-built rover with a mission to take photos and send them back to Earth as it drives across the lunar landscape. Once Peregrine lands on the moon, IRIS will deploy to the surface to begin its mission. And here we have another Carnegie Mellon University payload called MoonArk. MoonArk is seen as a cultural museum to the moon. Comprised of 4 independent chambers and weighing a combined total of 10 ounces, it contained hundreds of images, poems, music, nano-objects, and earthly samples. Next, we have Colmena, a fleet of micro-rovers and the first Latin American scientific instrument ever sent to the moon. Consisting of 5 small rovers, it will demonstrate a coordinated moon exploration. Lastly, we have the DHL Moonbox. Former astronaut Richard Garriott and thousands of others from around the world have sent small mementos to link life's meaningful moments with our nearest celestial neighbor. Now, this is just a snippet of the 20 payloads aboard Peregrine. Again, you can find the full list on Astrobotic's website. Now back to Megan.
We are now less than 10 minutes away from Peregrine separation, so let's get back over to the ULA team and Amanda Sterling to take us through that.
Thanks, Megan, and thanks to those of you who are still following mission progress of ULA's Vulcan Cert-1 flight. For those who are just tuning in, I'm Amanda Sterling, and I'm here at ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. ULA's inaugural Vulcan rocket lifted off on its first flight test at 2:18:38 a.m. Eastern, and all systems continue to operate nominally.
One-minute, 1-second burn. And we've begun pressurizing the propellant tanks in preparation for second burn. Coming up on LH2 pre-start. LH2 pre-start.
This is Vulcan Mission Control at T plus 43 minutes, 8 seconds. Coming up next is the second main engine start of ULA's Centaur upper stage. Let's listen in.
Change to the start position, everything looking good. About 15 seconds to mess. We have ignition, full thrust, 2 good engines. Everything looking good.
This is Vulcan Mission Control at T plus 43 minutes, 57 seconds. As we approach Peregrine separation, let's learn more about the first spacecraft to launch in NASA's new CLIPS initiative to have American companies send its science experiments to the moon.
Astrobotic is a full-service lunar company. It starts with our terrestrial testing and development services that can build propulsion systems and test propulsion systems on Earth, to the sensors that make precision landing possible, to our rovers that will deploy down on the surface of the moon, to one day our power systems that will deploy on the moon and provide sustaining power for infrastructure on the surface. Astrobotic is in all of those businesses, and we are in the business of making space accessible to the world, and the moon is just the beginning. The big thing that we're known for is our 2 lunar missions to go to the surface of the moon. Our first one is about to launch, and our second one flies in 2024. The Peregrine mission is important because it's among the first commercial missions to return to the surface of the moon. This is the first time as a nation going back since Apollo. It's the first time for 6 nations that could land on the surface of the moon with our mission. This is the dawn of a new era of affordable, routine, regular access to the surface. What that means is our nations and world scientists can access the moon on a routine, regular basis. They don't have to wait for the culmination of their career for one single super mission. They can go back again and again and again. It's the beginnings of learning about the resources on the surface of the moon, and potentially one day turning those resources into something that we can use in space, and maybe one day return back here to Earth.
Peregrine's development was a years-long process that included many people, like engineers, welders, and technicians, who designed and built the spacecraft.
Landing a spacecraft on the moon is very complex. The team worked long hours to get Peregrine to the launch pad. To be on the pad today with our spacecraft strapped to a giant 200-foot tall launch vehicle ready to blast into the heavens it's a little surreal. It's a moment I've been dreaming about for 16 years. And to see it all on one rocket, it's terrifying and exciting and thrilling all at once. Our Peregrine lunar lander starts its journey to the moon in Florida on a Vulcan launch vehicle. That will blast us into translunar injection, heading us straight out to the moon, where we will enter lunar orbit and start our descent down to the surface. At this point, engines are firing, all eyes are tuned in, and as we soft touch down on the surface of the moon, that marks the beginning of our surface operations and our payloads deploying. As a nation and as a company, as individuals, we all persevere to overcome challenges, and we're going to continue to do that. And this first mission is just our first step, our first attempt to make space accessible to the world, and it certainly will not be our last.
Pressures.
This is Vulcan Mission Control at T plus 47 minutes 8 seconds. We're a few seconds from the second main engine cutoff. Here's Rob Gannon.
30 seconds to nominal MECO. $20 seconds. And we're going to open loop on PU. Coming up on cutoff. We have cutoff. Everything is looking good. And we are now in a 2-minute 49-second coast phase of spacecraft separation. We've got full settling going after MECO. And we're reorienting to spacecraft SEP attitude. And continuing to maneuver to our MES2 attitude. And we're inside a minute and a half to spacecraft separation. Body rates are nulling out. And this mission does call for a roll spin for spacecraft separation of 0.5 degree per second. We'll be starting that maneuver shortly.
This is Vulcan Mission Control at T plus 50 minutes 10 seconds. Vulcan has executed all mission events expected, and we are now approaching delivery of the Astrobotic Peregrine commercial lunar lander into a highly elliptical orbit, more than 220,000 miles above Earth, to intercept the moon. Let's return to flight commentator Rob Gannon as we approach separation.
We are spinning down. And we are now in a 28-minute coast period to third burn of Centaur.
This is Vulcan Mission Control at T plus 51 minutes 6 seconds. We just heard confirmation of Peregrine spacecraft separation. I'm now back with ULA President and CEO Tori Bruno. Tori, our first Vulcan rocket just delivered its first payload to orbit. How are you feeling?
Yeehaw! I am so thrilled. I can't tell you how much.
Absolutely. And again, we're not completely done with the mission here today. Is there anything else that you want to share with the audience?
I am so proud of this team. Oh my gosh, this has been years of hard work. So far, this has been an absolutely beautiful mission back to the moon and off to our next burn, where we will do our final payload deployment to that heliocentric orbit for the memorial. Our team has done such a good job. Bravo, Zulu to everyone. This is just, it's hard to describe.
Yeah, absolutely. I feel that too. So again, thank you so much for joining us on our show. Congratulations, and we'll let you get back to finish the rest of the mission.
Congratulations to you. Give me a hug. All right.
Minutes 40 seconds. Time, we're going to pass the broadcast back to the NASA team to continue mission coverage. We'll be joining back in as we approach the final engine burn. Over to you, Megan.
Thank you, Amanda, and well done, ULA team. So throughout the broadcast, we have been telling you about the 5 NASA payloads that are flying on this mission. We've shown you in depth 3 of them, and now we have the final 2. So NASA's Goddard Space Flight Center has 2 payloads aboard today's flight, and one of those is the Peregrine Ion Trap Mass Spectrometer, aka PITMAS. Its job is to understand the release and movement of lunar surface volatiles like water.
My name is Barbara Cohen. I am the principal investigator, or the lead of the science team, for the Peregrine Ion Trap Mass Spectrometer. PITMAS, the instrument I work on, is going to inform our understanding of the volatile cycle on the moon. That is water, carbon dioxide, methane, all sorts of fun molecules that we want to measure on the surface of the moon and in the lunar exosphere. So we are trying to learn about the water at the poles by going back to where it comes from, to the solar wind and micrometeorites that are coming in now, and understanding how much is there now, how much could be there in the future, how much was there in the past. We're interested in that atmosphere and what it's made out of, and that's what PITMAS will monitor. The reason it's so important to measure the lunar exosphere is because that is a process that's happening today that includes all of the things we're interested in for human exploration. Our Artemis program is going to the South Pole because there are resources there. If you don't have to bring your water with you, if you can use the water that's there, that saves you a lot of mass going up with your astronauts.
And the 5th and final NASA payload we want to show you is the Laser Retroreflector, or LRA. It's a unique type of mirror used to measure distance, and this is why it's so critical for future missions.
My name is Xiaolui Sang. I'm a LiDAR instrument scientist and also work on other laser instruments. The instrument is a laser retroreflector arrays. It's a small retroreflectors mounted on a shell, on aluminum shell, support shell. It retroreflects laser light back to where it came from. The purpose is to, number one, to have a fiducial marker, a precise fiducial marker on the lander so that we know exactly where that is on the lunar surface. It serves as a landmark for future missions if you want to go back and land it there. When you shine laser on it and it reflects right back at you, so it doesn't matter which way you're looking at it. And so that will help us to range from orbit to the lander as it passes overhead.
All right, it's now been about 55 minutes since Vulcan and Peregrine lifted off from the space coast of Florida. Let's get back to Olivia and the Astrobotic team as they work to confirm acquisition of signal with their spacecraft.
Thanks, Megan. As you saw, we just got confirmation that the Peregrine spacecraft separated from the Vulcan rocket, and now we are waiting to establish a space-to-ground communications connection. We expect for this to take a few more minutes. This connection helps engineers in Astrobotic's Mission Control Center pass commands, receive telemetry, and determine the location of Peregrine in space. Peregrine will be utilizing NASA's Deep Space Network, or DSN, their 34-meter dishes in Australia, Spain, and California. These dishes are the same suite used to communicate with the James Webb Telescope, as well as other historic missions. So our flight director on console, Alex Van Hoven, will be calling out what is happening in Astrobotic's Mission Control Center. And now, as we look at Astrobotic's Mission Control Center, you can see the rows of our staff all monitoring the spacecraft. In the room today, we have 3 of 6.
This is Mission Control Flight Director announcement. Repeat broadcast, this is Mission Control Flight Director with an announcement. The mission team is still waiting for communications with Peregrine with earliest AOS at 080905 UTC in approximate 2.5 minutes. To repeat, the mission team is still waiting for communication with Peregrine with the earliest AOS expected at 080905 UTC.
And folks, that was Alex Van Hoven, our flight director on console. He is calling out UTC times, or sort of space times, and we're waiting for that acquisition of signal with the Peregrine spacecraft.
Correction, earliest AOS at 0818 UTC. Earliest AOS at 0818 UTC.
Now you can almost see Alex Van Hoven in the back row, right below the eye in Astrobotic. You can kind of see his head. Maybe he'll stand up for us at least one time, we'll see. He's very focused and busy. Today we have 3 of 6 flight directors on console for launch. Once we establish communications with Peregrine and the spacecraft officially begins its journey towards the moon, the flight directors will work in shifts so there is always one present in mission control. I would ask them to all give a wave, but they're definitely laser focused on their screens, checking up on the spacecraft. Now Alex, he's giving us those live updates, and he is also senior aerospace engineer, and he oversaw the development of Peregrine's in-flight procedures. He developed his flight expertise as part of NASA's Goddard Space Flight Center.
Broadcast, Mission Control Flight Director announcement. I repeat, broadcast, Mission Control Flight Director announcement. At this time, Astrobotic has confirmed that we have established communications with Peregrine, and we are now receiving live telemetry. I repeat, we have just established communications with DSN and can confirm that we are receiving telemetry from the satellite.
Now confirming, my goodness, we have received signal with the Peregrine spacecraft, and we are communicating it with it here on Earth. You just heard it from Alex. The team will begin sending commands to Peregrine to continue its journey to the lunar surface. What an incredible day. Now, thank you so much for continuing to tune in with us to watch this historic launch of Astrobotic's Peregrine lunar lander on its journey to the moon. I'm Olivia Chapla with Astrobotic, and it is such a happy day for Astrobotic. I'm kind of speechless. So back to Megan at the hostess. Thank you very much.
Hey, congratulations, Olivia. I know that must have been really nerve-wracking to see such a big moment and it being finally here. So congratulations to her and the rest of the team. And actually right now here with me, I have Andy Jones, and he is the Director of Landers and Spacecraft for Astrobotic. And Andy, I saw you were over off the camera, but I saw you go, yes, as soon as we confirmed acquisition of signal. So talk us through that. How are you feeling?
Relieved, more than anything else relieved. I mean, getting communication is just so important to everything else we want to try and do. So now I can start enjoying the moment, enjoying the excitement of getting into space.
Yeah, at least you didn't have to wait long. You know, there was a window, right? We got it right at the beginning of the possible window.
So just a credit to all the great work the team has done to actually get it, to acquire it so fast.
Yeah.
It's just a brilliant set of machine, brilliant people working on it. So
yeah,
very proud.
Yeah, what would you say to the team? You know, again, I know that you guys have been working on this for years. What would you say to them as it culminates in this moment right now?
Get back to work. No.
You don't even, not even going to give them a break. Okay, we're hard-working folks at Astrobotic, guys.
No, extremely proud. The team should be extremely proud of themselves. It's been a fast road, a lot of setbacks, a lot of ups, lots of downs. The team took everything in their stride and, as you can see, achieved remarkable things. So proud of everybody, what they've done. Inspirational to everybody.
Yeah. And what's next for Astrobotic and NASA? You know, it seems like we're going back to the moon for a second time, huh?
It is. So once obviously successful completion of this mission, we have Griffin, which takes the Viper rover to the moon late 2024. Following that, we have as early as 2026, a tipping point where we do a demonstration of power transmission across the lunar surface. And also, Astrobotic is part of the national team led by Blue Origin to take humans back to the moon, and we're part of the cargo lander system for them.
So a lot of things to look forward to.
Lots to look forward to. Yeah.
And just by one last question for you, I mean, just what do you think of this new initiative that NASA has to really bring in all of these small U.S. companies to hopefully help us all go back to the moon?
Its initiative is incredibly important. It allowed a small company like Astrobotic to actually deliver a lander to the moon. We'd have never been able to achieve it without that. But the best thing is it's bringing a lot more creative minds, new thinking to the table, and that will help us accelerate the technologies needed to get us back to the moon and have a robust resource and presence on the moon. So the more, it's very important for us to be there, and it's just helping us get there much faster.
Andy, thank you so much, and congratulations again.
Thank you very much.
And that's going to do it for us here at Kennedy Space Center. Thank you for sharing in the excitement of NASA's first CLPS launch. Now on its own, the Peregrine spacecraft will coast for an expected arrival at the moon on February 23rd. And coverage of that landing, one of the first U.S. landings on the moon in over 50 years, that will be broadcast on NASA TV and NASA Plus. For those of you watching on ULA platforms, the ULA version of the simulcast will continue in a few moments as they await another milestone in this inaugural Vulcan flight. Again, thank you so much for joining us. We leave you now with a final look at today's historic launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. And liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
Engines operating normally. 2 good SRBs, hitting peak pressure on the SRBs. Everything looking good.